Today we will talk about work. What is work? We all are pretty much familiar with this term work as we are doing work in our daily life. We are cooking, we are eating, we are jumping, we are pushing, but this term work done is different from the way it is being used in our daily life to the way it is being used in science. Let's take an example. Case 1. Person is pushing a rock. In this photo, you will see there is a person who is applying a force on a rock, but he is unable to move the rock. There is no displacement of the rock, so no work is done. Here we will not consider how much force he has applied, how long he is being applying the force. We will consider the fact that there is no displacement of the rock, means no work is done. Case 2. Person applying a force on a book. Let's say there is a book placed on a table and there is a person applying a force F causing a displacement by S units. Since there is a displacement of the book, we will consider that work is done. From these two examples, we are clear that there are two things which are important for work. One is force, other is displacement. If either of these are absent, we will say that no work is done. Work done is equal to force into displacement. How we will define work? Work done by a force acting on an object is equal to the magnitude of the force multiplied by the displacement of the object in the direction of force. Work has only magnitude, it doesn't have any direction. Let's say if a force applied is 1 Newton and it is causing a displacement of 1 meter, how much work is done? So work done, W is equal to F into S. So force 1 Newton, S displacement 1 meter. So 1 Newton into 1 meter is equal to 1 Newton meter. And this Newton meter is equal to joule. 1 Newton meter is equal to 1 joule. So how we will define joule? 1 joule is equal to the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of force, and the unit of work is joule. There are two types of work. One is positive work, other is negative work. If the force acts in the direction of the displacement, it is called positive work. But if the force acts opposite to the direction of the displacement, it is called negative work. Let me explain you with the help of two examples. Case 1. Here you will see there is a boy who is pulling a trolley and the trolley moves in the direction of the force. So force is applied in this direction, displacement is there in this direction. The force and displacement are in same direction, we will say positive work is done. Case 2. We'll say there is a car moving in a particular direction and a person is applying a force in opposite direction causing the car to stop. Car is moving, person is applying force, car stops. The force is applied in this direction and the displacement is in opposite direction. Force and displacement are in opposite directions, so work done is negative. Now we will try to solve some numericals. Question 1. A force of 7 Newton acts on an object. The displacement is 8 meters in the direction of the force. Let us take that the force on the object acts throughout the displacement. What is the work done in this case? This is an object, force applied is 7 Newton and the displacement is 8 meters. So we have to calculate the work done. So what we have been given? Force 7 Newton, displacement 8 meters. So work done will be F into S. F 7 newtons, S 8 meters. So 7 Newton into 8 meter. 7 into 8 is equal to 56 Newton meter. 56 joule. So work done by the force is 56 joule. Let's solve another example. A pair of bullocks exerts a force of 140 Newton on a plough. The field being ploughed is 15 meter long. How much work is done in ploughing the length of the field? So what we have been given, force 140 Newton and displacement is 15 meters. Why we have considered displacement 15 meters? Because the length of the field is 15 meters and the bullock cart has to plough the field in the lengthwise direction. So displacement is 15 meters. Work is equal to force into displacement. 140 into 15 is equal to 2100 Newton meters. So 2100 joule. So how much work is being done by bullock is 2100 joule. Let's take another example. A porter lifts a luggage of 15 kgs from the ground and puts it on his head 1.5 meters above the ground. Calculate the work done by him. So what we have been given, mass 15 kgs and displacement 1.5 meters. We have to calculate work. So work is equal to F into S. So we don't know what is the force. We have to first calculate the force. You know, when there is an object at certain height, there is a constant gravitational force which pulls it towards the earth. So there is a force and that force has the magnitude of mass into acceleration due to gravity. F is equal to m into g. So we have m 15 kgs and g is a constant having value 9.8. So F is equal to 15 into 9.8 is equal to 147 Newton. So now we have force. We can easily calculate work. Work is equal to F into S. So 147 into 1.5 is equal to 220.5 Newton meters. 220.5 joule. So work done by the porter is 220.5 joules. Thank you.